All right, in this video, we're going to go over the topics of the different variables of a data set and what we call measures of data. All right, so when conducting experiments, there are two different types of variables that are of interest to the researcher. You have something that's called the explanatory variable. What the explanatory variable is, it's a variable that tries to explain the changes that's happening in the other variable. Different values of the explanatory variable are called treatments. Okay, so that may not be clear, but just give me a second when we get to an example here. Then you have something called the response variable. Okay, the response variable is the variable that is affected by changes in the explanatory variable. So for instance, let's say we're treating cancer. Okay, and so the explanatory variable will be the different pills, the chemo treatments. That's the explanatory variable. The response variable will be the size of the cancerous tumor. Okay? Well, there's also potentially, when it comes to these experiments, something called a lurking variable. And so these are variables that can confuse your results or cloud the study results. For instance, a classic example is, let's say we own a coffee shop, right? And let's say we redecorated the interior of the coffee shop. And all of a sudden we notice that we got a lot more business. Well, you may be thinking, okay, the redecoration of the interior led to the increased business. However, what if I told you that a new apartment complex just opened up right down the street from us? So the lurking variable in that case will be we're getting more people because, well, there's an apartment complex that is bringing more potential customers to us. Okay, but in this class, we're going to focus on just the explanatory and response variables. For example, suppose that a researcher is interested in whether the amount of sleep that a student receives affects their GPA. What's the explanatory variable? What's the response variable? So think of the explanatory variable as the thing that we can adjust, or the thing that is adjustable. In this case, the explanatory variable will be the amount of sleep that the student receives. Therefore, the response variable will be the corresponding GPA of that student based off the amount of sleep that they get. Okay? But with this potential example here, there's a bunch of potential lurking variables. For instance, maybe part-time students have a lower GPA than full-time students because, potentially part-time students have full-time jobs, right? That would be a lurking variable. That's something that's not explained by the explanatory variable. Okay. Next, what are some different types of data? So I alluded to this in the first video. Now we're going to formally define it. So qualitative data. This will be your data that consists of non-numerical measurements. Typically, these are things like names and categories. So things like a person's eye color. So let's take this back. So variables are characteristics of your data set. Okay? So if you think about it, whenever we're dealing with a group of people, let's say our data set is a bunch of people in the classroom. What are some characteristics, aka variables, of people, of human beings? How can we separate people? We can separate people by their gender. That's a variable. That's a characteristic. Eye color, hair color, weight, age, height. Those are different types of data, of variables. And so what we're going to do here is that you treat, numerically speaking, you treat age different than you do eye color. For instance, I can add two ages together, right? If one person is 23 and another person is 20, that means their total age is 43. But can I add eye color? Can I add brown to green eyes? No, I can't. So that's what this type of data is alluding to. So qualitative data, like I said, is data that's non-numerical. So things like your eye color, your hair color, okay? The name of your favorite chicken restaurant. On the other hand, quantitative variables These are numerical in nature, but we like to break down these numerical values into two different categories. So you have what's called quantitative discrete, and you have what's called quantitative continuous. For quantitative discrete, what we're dealing with here is that we're dealing with numerical data, but discrete means that there are gaps in the numbering system. What I mean by that is that think of counting. Whenever we count something, we go 1, 2, 3, 4. But even between 1 and 2, there's an infinite number of numbers that we are skipping over. So that's why we say whenever you have a discrete data set, you're dealing with something that more than likely you're counting. Okay. On the other hand, a continuous data set, quantitative continuous, is something where it fills in those gaps that the discrete left behind. Okay. So for instance, the number of minutes it takes you to commute to work. It could take you 50 minutes, or it could take you 50.5 minutes, or 50.555 minutes, so on and so forth. So whenever you're measuring something, sorry for the typo, whenever you're measuring something, that's going to more than likely lead to a quantitative continuous data set. Okay, here we go, some examples. Classify the following as qualitative, quantitative discrete, or quantitative continuous. So a randomly selected person's GPA. Okay. So first of all, we're dealing with a numerical data value here. So it's going to either be quantitative discrete or quantitative continuous. And so what that means is that now we have to look and understand, okay, a person can have a 3 GPA, right? 3.0 is what we call it. But you ask yourself, is it possible for a person to have a 3.15 GPA? Is it possible for a person to have 3.2257 GPA? Because all of those are possible, GPA is what we call quantitative, I'm just going to abbreviate here, quantitative continuous. Okay, because there's an infinite number of possibilities for a person's GPA. Okay. A randomly selected student's eye color. We already mentioned this earlier. We know eye color, you cannot perform any arithmetic with it, so it's not numerical. Therefore, eye color is qualitative. I'm just going to abbreviate that. Here's a tricky one. The zip code of a randomly selected Orange County resident. So zip codes are numbers. However, whenever we say something is numerical, it means that we can perform arithmetic. Just ask yourself, does it make sense? Is there any meaning behind us adding and subtracting zip codes? No. There's no meaningful reason for us to add zip codes together. And there's no law that says, there's no rule that says if you add 2 zip codes together, you get back another zip code. So even though zip codes have numbers in them, zip codes are not a numerical data set. In fact, a zip code is a category of where you live with respect to your city. So therefore, zip codes are qualitative. What are some other kind of weird numbers that are not quantitative? Think of your social security number. Doesn't make sense to add and subtract social security numbers. It doesn't. What about a person's phone number? Once again, for it to be numerical, arithmetic has to make sense. No adding and subtracting of phone numbers makes sense. Okay, you got all kinds of numbers. You got, debit card PIN numbers, all kinds of numbers that are, even though they're numbers, they're not numerical. All right, and lastly, the number of people registered to vote in the state of Florida. Okay, well, certainly we could perform arithmetic with the number of people within a certain state. So it's numerical. So it's quantitative. The question is it quantitative discrete or quantitative continuous? So we know it's quantitative. Is it quantitative discrete or continuous? Well, think about it. Whenever we're dealing with people, we are counting people. Okay, you have either 0 people that are registered to vote, or 1, or 2, or 3, so on and so forth. But what you don't have is you don't have 47.2 people that voted in the last election. So because of that, because we can only count certain numbers there, the key word is count, this is quantitative discrete. Quantitative discrete. Okay, hope that cleared it up. All right, so the next topic is the levels of measurement. Okay, and basically, based off your levels of measurement, it kind of indicates what you could do with your data set. And so here, there's just 4 levels. Here are the 4 levels. You have what we call a nominal scale. So a nominal scale tends to typically be your qualitative data. And your nominal scale is just different names and categories. There's no order, there's nothing to it. It's just a listing of categories. However, if you're able to rank those categories or to rank those non-numerical values, you have what we call the ordinal scale. Word ordinal means that there's a order, a hierarchy. And once again, these tend to be your qualitative data sets. Okay. And then your last 2 interval and ratio scales, these are both going to be typically, not always, but typically, these are going to be your quantitative values, okay? Where the difference between them is this concept of what we call an absolute zero, okay? And what does that mean? An absolute zero means that the data set has a starting point, and you can't see me, but I'm putting that in air quotes, a starting point of 0, okay? Meaning that you start measuring that particular quantity at 0. If you do not start at 0, that means you do not have an absolute zero. And what that means is that you have an interval level of measurement. However, if you start at 0, when it comes to that particular quantity, of data, then you have what's called a ratio scale. Okay, let's see if we have a few examples here. So a ranking of the top 10 preseason college basketball teams. The question is, what's the level of measurement there? Well, we have the basketball team, so that's going to be a qualitative data set. So that kind of indicates we should be either nominal or ordinal. And the question is, do we have a ranking here? Well, yeah, right? Certainly number 1 is different than number 10 in the rankings. So what we have here is an ordinal level of measurement. Okay. Pizza toppings. All right, we're talking about your pepperoni, your anchovies, onions, peppers. Pizza toppings. If I'm just randomly listing pizza toppings, there's no inherent ordering. Therefore, it's just a bunch of non-numerical things. This is the nominal level of measurement. Okay. And I'm sorry, I forgot to mention, go back. So nominal, as we go from nominal, ordinal, interval, and ratio, we're increasing the level of measurement, and you are retaining the properties of the previous level of measurement. So for instance, the ordinal scale has everything that the nominal has, it just has now order. The interval scale has everything else the ordinal and nominal does, it just has something extra. And the ratio scale has everything. Okay. Oh, here's a good one. The temperature, okay, we have to be clear here, it's in degrees Fahrenheit, of a randomly selected classroom. Temperature. So temperatures, we're dealing with quantitative variables. All right, in fact, quantitative continuous, if you want to get technical. And so what we need to think about here is that this is going to either be an interval or a ratio level of measurement. What's the difference? The difference is, do we have an absolute zero? Meaning, does that particular data set start at 0? If we do not have that, we're interval. If we do have it, we are ratio. Well, temperatures, ask yourself, when it comes to degrees Fahrenheit, do we start at 0? Or another way to look at it, is it possible for us to have negative temperatures? I know we live in Florida, but yeah, it's possible to have negative temperatures. So because of that, we do not start at 0, and what that means is that temperatures in degrees Fahrenheit do not have an absolute 0. Therefore, temperature, that is an interval level of measurement. But the key here, folks, is that we did this in Fahrenheit. What if we did this in the units of Kelvin? I don't know if you remember your chemistry classes back in the day in high school. But Kelvin starts at 0. In that case, The temperature would be ratio because you cannot have anything less than 0 on the Kelvin scale. All right, here we go. GPA of a randomly selected student. GPA, think about them. GPAs start at 0.0 and go up from there. Because we're starting at 0, we have a absolute 0. We're quantitative, so this has to be a ratio data set. Okay? Because GPA start at 0. All right. Well, folks, I hope that helps you out with your next homework assignment. I will catch you in the next video.